Hello, this is Mrs. Repasky, and this is a demonstration of the single replacement reaction between iron metal and copper 2 sulfate. Here's a piece of iron metal, and if I put it in with the copper 2 sulfate, you'll notice that nothing happens. The copper sulfate stays blue, and the piece of iron stays lustrous and gray. These elements should react. Why? How do I know that? Because I know an activity series, and iron is higher than copper on the activity series, so it should react. So something must be preventing them from undergoing the reaction they desire to have occur. What could that be? Well, you'll notice that in the test tube, I have two solids. The iron is a solid. You can tell that it's solid because it's solid and it has its nice iron luster. And the copper 2 sulfate is also solid. You can hear it shaking around in there. The copper 2 sulfate, in its form presently as a blue crystal, that is an ionic compound, and ionic bonds are the strongest type of chemical bonds. So some type of energy or encouragement is needed to get the copper 2 sulfate ions to break away from each other. So the copper and the sulfate need to break apart. The Roman numeral 2 just tells you that indicates the charge on the copper ions. So I'm going to introduce distilled water. So I'm pouring distilled water into the test tube that has the copper 2 sulfate. I use distilled water because distilled water does not have other metals or other ions in it that can help or create a reaction. I'm just going to use the piece of iron, right, as my stirrer. And you can notice that the solution is starting to turn blue. That means that the copper sulfate is starting to dissolve. And once the copper sulfate starts to dissolve, then the iron should start to react. Oops. Some reactions are instantaneous, and some reactions take a little longer. So I'll let that one sit there for a little bit. Right? We'll see what happens. Here is another beaker that also has some copper sulfate. Right? And just to show that it's not just iron that doesn't react, I have some chunks of zinc. So here's zinc. Mossy zinc just means that it's chunks of zinc. So now I have a zinc metal with copper 2 sulfate. Notice that as I'm combining them together, nothing's happening here. Nothing is happening in the beaker, just like nothing happened in the test tube. So I'll add water. And this reaction is just a little faster. So zinc metal plus copper 2 sulfate, okay, changes the zinc. Notice that now the zinc has a brown color to it. The zinc metal now has a brown color to it. This is zinc metal plus copper 2 sulfate. Notice that the solution, instead of being the clear colorless form that distilled water is, it has turned into a blue color. Notice that the zinc also has a dark brown color and not the gray color that it had before. dark color that's collecting on the zinc is actually a dark brown, kind of a reddish brown color. And do you have an idea of what that is? Right? Well, that's the copper. That's the copper from the copper 2 sulfate. That's the copper is coming out. The copper has, since it is lower on the activity series, prefers to be in its elemental form, and elemental copper is brownish red. Okay? And that's how we can indicate that. Just as a reference, here is another piece of zinc so that you can see the reference. Okay. So here is zinc before it reacted, and the brown chunks in here. Notice they aren't the same color, right? They're not the same color. Let's see if the iron has changed. Ah, look, on the iron, right? The bottom part of the iron that was inside the solution, has turned orange on the bottom, right? So it does look a slightly different color than the reaction that's happening inside the beaker, right? But you can definitely tell that that's copper. There is definitely copper on that piece of iron. Notice the bottom half of the piece of iron is a completely different color than the top half. It hasn't reacted all the way through, it's just reacted on the surface. Reactions start at the surface and then make their way through the substance. This is a single replacement reaction that took place in a liquid solution. The ions need to break away from each other in order for them to react. Solid ionic compounds contain really strong bonds, so at room temperature, solid ionic compounds usually don't react. That is why solutions and using liquids, the dissolved form of ionic compounds, is really important in chemistry. Thank you for watching.